right, so from the final exam review, part 2, let's take a look at question number 3, which is calculating a CI. Now, you don't know that just looking at it yet, but I'm telling you that, and I'll tell you how we know. So in this question 3, it says that there's a cola machine in a cafeteria, and it's set up to serve a standard amount. So an employee wonders what is the average amount that amount of cola that's served. It says average amount. First of all, amount is going to be a number. So I'm thinking numerical, and then it says average, that's means. So that's numerical, right? Then it says, so he obtains a random sample of 61. So I'm just gonna start writing down some of this information because this is helpful for me. N is 61. From his machine, finds a sample average, that's X bar is equal to 8.70. And a sample standard deviation, which is S, is equal to 0.49. I thought I just lost you guys. My screen like kind of did something funny. There we go. Okay, so that's the information I gathered just from the first part. I still don't know what's a CI, right? So I have to look at the questions, the prompts. So in part A, it says to estimate, right there, the word estimate. That alone means CI. That's how I know it's CI. Estimate the mean amount. So estimate the numerical variable, you know, so it's the amount of cola servings for this machine with 95% confidence. So what I'm doing here is I need a 95% CI. That's what I'm going to calculate. Anytime we're calculating a CI, it's always point estimate plus or minus margin of error. Always. Okay, it doesn't matter what kind of CI we're doing. If it's for numerical data or categorical, it's always the same formula. It's just what I'm plugging in for each of these is what changes. So my point estimate for my numerical is X bar plus or minus. Now margin of error, remember we have our T or our Z value. It's T in this one because it's numerical at alpha divided by 2. I'll refresh your memory how to get that. And times standard error. So for numerical, it's S divided by the square root of N. Remember, we use the T curve because I'm using X bar in the calculation and S. So I'm using 2 numbers from my sample. Okay, so I'm going to start filling in some numbers. So I have 8.70 plus or minus. I'm going to leave a spot for my T and 0.49 divided by the square root of 61 here. So now to find my T value, I'm going to grab my calculator. You could also use the tables, right? The tables will be provided in my courses. They're there. So just in case you need them for a problem, they are where the syllabus is, the same location. Okay, so here's my calculator. Sorry about the glare. Try to do my best here. So I need my T value. So I'm going to go to distribution, so second vars for my distribution, and I'm looking at inverse T, that's option number 4 right there. And I just don't remember what it needs, right? So if we don't remember, go into it. It says area and DF, degrees of freedom. So it needs to know the area. So I need to draw a picture because I can't remember what's going on, right? So let's draw a picture. It refreshes our memory. So remember a CI is always the middle. In the middle is the 95%. The area is this area to the left of whatever data value I'm trying to find, right? So I'm using inverse T. So I'm trying to find a data value. So I need to give it the area to the left of that data value. Now you can choose whichever data value you want. Just remember, this one on the left is the negative and this one on the right is the positive because this is symmetric. So I'm going to kind of, I normally do this. I use the left because when I use the left, I feel like there's like less error because if you use this one on the right, you need 95 plus that one on the left. So you need to find it either way. So I need 100% minus 95% to get that 5%. That's 2 tails divided by 2 is 2.5%. So this is 2.5% and this over here is 2.5%. So I'm going to write this as 0.025 because that's what my calculator needs. This is the area to the left. It needs the decimal. So 0.025. Degrees of freedom is n minus 1, which is 60, because it's 61 minus 1, and then I can move forward. Right there, -2. Okay, so on this side I have -2.00, and on this side is +2.00. Just know it's always symmetric. You don't have to fill out this whole chart. I just really needed to see the area and the tail so I could figure that out, and what I'm plugging in to my inverse t. So here you can use positive or negative. I typically use the positive even though I found the negative because it's the same number, right? It doesn't matter if you plug in negative or positive here because you're adding and subtracting. So for this, when I divide 0.49 by the square root of 61 and multiply it by 2, I end up getting 0.125, I believe. Yep. So now for my upper bound and my lower bound. My lower bound is 8.70 minus 0.125. And my upper bound is 0.70 plus 0.125. See how the point estimate is the middle, right? It's the middle of my CI. So this is 8.575, and this one is 8.825. So my interval is 8.575 up to 8.825. That's my CI. So when you're solving for a CI, there it is. Okay. Now part B says, what is the point estimate and what is the margin of error? Well, I already know what it is. Point estimate is my X bar, which is equal to 8.70. And margin of error is everything on the right side. So that's the 0.125. That's what I'm looking for. I just want you to pick that out. Okay. Part C says, write a concluding sentence. So I want you to interpret the CI, write the conclusion statement for the CI. So this is where I say, we are 95% confident that the population mean amount of cola served is between these two numbers, 8.575 and 8.825. There it is. So here's my concluding statement about my CI. The important parts here to inform whoever's reading this, the confidence level, to include population mean or population proportion for categorical, and then what you're talking about, amount of cola served, right? And of course, my CI values. That's the important part. Okay? If you want to write it in a different way, it's completely up to you, and it's fine with me. You do not have to write it the way I write it. Okay? So that's my interpretation or my conclusion statement. Now in part D, it says the machine is supposed to serve 9 ounces, but some employees think it's less than 9. So I'm going to write this down, less than 9 ounces. So I want to know, does our sample show that, like, can we be 95% confident that the serving is less than 9 ounces? So is this true? Is it true that it's less than 9 ounces? Well, I'm going to look at my CI. Is my entire confidence interval less than 9? It sure is, because look at my upper bound is 8.825. So I can say yes, since the entire CI is less than 9 ounces. Okay. Remember, the only one that it is in the middle is when it says it is. So if the question was, are they 9 ounces? Then you would say no, because 9 is not inside the CI, it's outside. So it can't be 9, according to our sample. That's what we're saying, okay? Part E says, if we obtained 100 samples and we computed the 95% confidence interval for each of those samples, each of those 100, we would expect how many of those CIs to contain the population mean? Well, this is my confidence level, so it's the 95. So if I have 95% confidence, I expect 95 out of 100 intervals to have that population mean mu in it. So that answer is 95. I'm going to squeeze F in over here. I have probably enough room there, but that's all right. So F, if the confidence level is reduced to 90%. So this is one where it's kind of like the concept. There's no calculation. So if it's reduced, so if I go from 95 down to 90, what does my confidence interval look like? It looks like it's narrower, right? It's going to be smaller, the interval. It will be narrower. So that's answer D. Any questions on this number 3 for me? All right. I'll scan that one in. Show the video, maybe. Maybe I won't scan them, maybe I'll just do the video. All right. What else do you guys want to see? So the confidence interval, we have empirical rule. Anyone wants to see that? We have regression, box plot. I think any of those 3 would be really good. We probably have about time for 2 more. Anyone have a preference? Box plot, awesome. Let's do it. All right, let's do look at number 7. All right, number 7, looking at a box plot. We don't know what's a box plot yet, but we will. Okay, so it says the following set of data gives ages of 64 offenders for auto theft in Michigan. And so then you'll see all the raw data, right here. I will not give you this much raw data. I might give you raw data, but not this much on the exam because it's just stressful. So for part A, it says to compute the following values for the sample. It says sample right here. That is key. You know why that's key? Because it asks for mean, standard deviation, right? There's 2 different calculations, one for population and one for sample. We're almost always working with a sample. It's like we are always doing S, right? Not sigma, okay? But right here's the key. You see it. So for here, I'm looking for X bar, S for my sample standard deviation, the minimum value, quartile 1, the median, which is quartile 2. I'm going to write that in there. It's the same thing. And then it asks for quartile 3, not 8, and the max. Okay. So if you look right here to here, so the min, quartile 1, median, quartile 3, max, that's my 5-number summary. As soon as I see a question that asks for that, I'm thinking box plots right away because box plots the graph of the 5-number summary. All right, I'm going to show you guys on the calculator how to do this. Just to refresh memories, right? That's all. We already know how to do it, but refresh memory. Remember, you could always find like all these directions in the different team assignments. Some of them are just out there where the syllabus is as well. So for this kind of problem, I'm not going to actually do it because I'm not going to enter 64 numbers right now because it takes too much class time, so I don't want to do that. But if you're doing this problem, you're going to hit stat right here and edit, that very first option, edit. It brings me to my list. I would just go to a new list. I would just start typing in and put in all my 64 data values, okay? And then when I'm done with that, I would get out of the list and I would go back to stat here and I would arrow over 1 to calc. Look at that very first option, 1 variable stats. That's what we're doing, right? We have 1 variable and I want the stats on those 1 variables. So I'm going to do it on one of my other lists that I already have in there, just to be quick. I'd put whatever list I have my data in. Okay, I'd put that in and I'd go to calculate. So you'll see we get X bar, S, that's my sample standard deviation, not sigma, this population, so I need S, right? Gives me N, and then look, it has this little arrow right here. That means I can arrow down, I'm gonna have more information. Look at, there's my min, there's quartile 1, my median, quartile 3, my max. There's my 5-number summary, okay? So just know that it's all right there in one location. Same thing on Minitab. You'd enter all your information into one of the columns and you would go to stat descriptive statistics, excuse me. And then, you know, if you've been working with Minitab, you just check the little boxes of all the data you want. Okay. So there it is. So I have it. So I'll just give you what I have, as you can see right here. So for the mean, we have 21.84. For S, I have 11.51. Okay, that's my SX, that's my sample standard deviation. Min is 12. Quartile 1 is 15.5. Quartile 2, or my median, is 17.5. Quartile 3 is 22.5, and max is 67. Sorry, I had to take a drink of water. I've like this thing, like the last like week and a half, like my throat's really dry. Yeah, the school of that. Kind of kicked me off campus for a while. They don't like it when you're not feeling 100% yourself, although I feel fine. All right. Anyway, sorry about the sun. Here it comes again. I love the sun. Don't get me wrong. It's just positioned just right where it's distracting for our class. Let me know if this is too distracting, the shadows, and I can close my blinds. All right, part B says build a box plot. And it wants me to show the fences, and it wants me to show, that's too much. Now it wants me to show the sample mean with like a plus with a circle or asterisk. Hang on, guys, I'm just gonna shut these. I mean, I'm so happy to see the sun, but it wasn't sunny when class started. It's one of those days. It's just a normal Rochester day, I guess. All right. So for my box plot, what you're going to be given, if you have to do a box plot, would be like a line, right? Sometimes I think on exam 1, I maybe gave you a scale. I can't remember. I didn't even ask you to draw me a box plot, right? You might have to draw a box plot on your own. And the reason why I don't have you do it for me, because we're online, it's just too hard. So anyways, I'm going to take a look at all my data. This is all in order, right? Ascending order, so it starts from smallest, works my way up to the largest, which is really nice. So I could see the minimum's 12 and the max is 67, which I already knew from my 5-number summary. So I just need to incorporate all those numbers in here. So I'm going to start over here at like 10 and just count by 10s. I was going to just count by 5 right there. Hopefully I didn't miss a number because I'm like not paying attention. Okay, that looks good. That looks sufficient. So now I'm always going to draw my vertical lines for quartile 1, 2, and 3. So 15.5, 17.5, 22.5. It doesn't have to be perfect. It gives me an idea. And I'm going to go ahead and put my mean on there. I'm going to put it with a little plus with the circle. It's how it looks most of the time, but if you're doing it on your own, you don't have to do that. But 21.84, somewhere around there. Now remember with the box plot, you have like these little whiskers, right, that go off. But before you do that, they go to the max and the min, but remember the max and min that are not outliers. So the outliers are kind of a separate thing. So I need to see which numbers are outliers, if I have any. I'm guessing I have some. So I have a number all the way up here at 67, and look where my box is. I'm guessing there's some sort of outliers in here. So I'm going to calculate that lower fence and my upper fence. And actually, this is what part C asks me to do. So it would have been nice, actually, if part C asked me under A and then asked me to draw. But that's okay. So hopefully when you're drawing a box plot, you realize you have to do this first. So my lower fence is quartile 1 minus 1.5 times the IQR. And upper fence is quartile 3 plus 1.5 times IQR. So off to the side, I'm just going to mention what the IQR is over here. IQR is quartile 3 minus quartile 1, which leaves me with 7. 22.5 minus the 15.5. I'm just going to plug my values in. Quartile 1 is 15.5 minus 1.5 times 7. Multiply that by 7 times 1.5 and subtract it from the 15.5. I'm left with 5. So my lower fence is down here at 5. Now my upper fence is 22.5 plus 1.5 and 7. I'm going to multiply those, add it to 22.5, and I get 33. So that's up here someplace. There's my fences. I definitely have outliers because my data goes all the way up to 67. So let's take a look at our data. So right here is 30. I already said it's in order, and then my next number is 34. So any number after 30 here, which is this whole bottom row, those are all outliers. I'm going to just put those on real quick, and then I'll get to my whiskers. So I have 34, I have 36, 43, 46, 50, 54, 59, and 67. There they are. Those are all my outliers marked with asterisks. Now let's take a look at my whiskers. How do I know where to go? Remember, the whiskers go to the values inside the fences. So for my upper side, it's the largest value in my data set inside the fence. And for my lower side, it's the smallest value inside the fence. So on the low side, the min is 12, the fence is 5. So the min is inside the fence. So I can go ahead and put my little whisker to that 12. Now for my max side, I have to go back to my raw data and take a look. So the fence cutoff was right here, right at 30. So 30, 34. So 30 is the largest value inside my fence. So it's the largest value of data value with like less than 33. Try to spit it out properly. And there it is. There's my whisker. So there's my official box plot. Now it wants to know in part C, are there any outliers? And if there are, then what are my cutoff values? So here they are, and then you would just write yes, and they're all these numbers. Be all the numbers in the bottom, that bottom row of the data set. Okay. And then part D, it wants to know from the box plot, looking at this, what shape would you say? So remember, when you're looking at the shape, you're going to compare mean versus median. Mean is this plus sign, right? Median is the middle vertical line. So mean is greater than median. It's to the right. That means skewed right. So you should have seen something like that with histograms on the multiple choice review. So don't forget how mean and median compare tells you the shape, right? Mean equals median would be symmetric. Mean less than means skewed left. So remember, the mean gets pulled with the skew. All right, so that is problem 7, the box plots. Any questions on that for me, guys? Alrighty, let's take a look. What about a regression problem? You guys want to look at that? 8, yep, that's exactly the one I was thinking. All right, awesome. So I feel like this is a good one to review. We haven't really done regression in a while, and I'll show you the calculator steps and stuff. Just know Minitab is very similar, right? Okay, problem 8, we're talking about the shelf life of dry cereal. So the shelf life depends on how long something is there for this dry cereal, and what they're concerned about is the moisture content, right? Because you don't want to have moisture in dry cereal because it's no longer dry. So hopefully that all makes sense. So if you take a look at the data, I'm just going to show you what I have right here. So if we take a look, it says time on shelf X, and then it has these numbers, right? So that's the number of days. And then below it says moisture content Y, and then it has the moisture content, which is a percentage, right below it. These are pairs, right? So 0 and 2.8 is a pair. 3 with 3.0 is a pair. 6 with 3.1, that's a pair. So when we're looking at XY, you should always think regression. And when we're thinking about regression, think about like these pairs, right? It's an XY pair. It's not just X and then Y, like randomly, okay? All right, but maybe looking at that, maybe we don't know yet, but we'll know soon because the questions will prompt us. Part A, it's a multiple choice. Which of the following is the definition of correlation? As soon as you see correlation, we only talk about correlation in chapter 4 with linear regression, right? So I got to think about, before I even look at the options, I just want to think about myself, like, what does correlation mean? Correlation, like, what does it give me, right? So correlation's that value R. That's what it is. So R gives me that strength and direction of a relationship between X and Y, not just any relationship, but a linear relationship, right? So it's only for linear. Remember, for nonlinear, you're going to get an R value close to 0. It doesn't mean that there's not a relationship. It just means it's not linear. So R is linear. So let's take a look at the options. The first one says measure of cause and effect. No. B says strength. That sounds good. Of a relationship between two variables. Yes, but maybe a little bit more can come from that. And then C says strength and direction. Yes, definitely, of a linear relationship between two numerical variables. That's it to a T. That one is like all the details are very specific. And then let's just make sure D isn't correct. Measure of indirect relationship. No, I'm not going to read anymore. I know it's not that one. So here, what correlation means is answer C. Okay, let's move on. Part B. What is the value of a correlation for this data? Okay, so I already put it into my calculator because one of my other classes asked me to do this one. So again, you would go to stat edit and you would put all your data in. So here are my list 1 and list 2. Remember, sorry, I just have like that tickle. For the first one, it's 0 and then 2.8 for Y, right? So you make sure you have them in order. You don't want to get those out of order. So I'm going to get out of this by second quit. I'm going to go back to stat and then arrow over to calc. Option 4 is my linear regression, okay? Before I get into this, I need to make sure I'm going to get R and R squared. And remember, I need to have my diagnostics on. Now, last week, or no, maybe it was the week before, I dropped my calculator when I was in class. And when I did that, my batteries came flying out, my calculator reset. I lost everything, which I don't care. But I lost everything, meaning my diagnostics got turned off because it reset. So when you have that, I'm going to just show you how to do it just to refresh your memories. And you guys, you could always ask me in the middle of the final exam if something like this happens, because I'm not examining you on your diagnostics on your calculator. So I need to go to second 0. So see how it says catalogs? I'm going to click that. I have this catalog. I need to look for diagnostics. Now, D isn't down very far, but it kind of is. Like I have to go really far here. All of a sudden, it'll just pop up. Excuse me. There it is. Diagnostics on. Okay, so I'm going to click enter, but I'm not done. I have to do enter one more time, and it'll say done. There it is. Okay, so now my diagnostics are on. I'll get R and R squared with my linear regression. I'm going to go back into stat calc. Option 4, linear regression, AX plus B. So when I get in that, I need to tell my calculator which one has my X values, which one has my Y values. So it is list 1 and list 2. And I can go right on down to calculate and enter. Sorry, I'm coughing more now than I was all day. My throat is dry, evidently. All right, so let's see what B is asking for. What is the correlation value? So B is asking for my value of R. So I'm going to look, R is equal to 0.9526. I just have to write it down. I already know what the meaning of it is. We just talked about it up here in part A. Okay, let's move on to part C then. So part C says compute the least squares regression line. I just did it, right? Y equals AX plus B. So it's this equation, but really we call it Y hat, right? Because the little hat means it's predicted values. So Y hat equals AX plus B. So I'm going to look. A is 0.04462. So I'm going to just round it, 0.0446. And that's multiplied by X plus my B, which here we could see is 2.7. So I'm trying to hold it so you guys can actually see it. And then better some days in certain positions than others. 2.78551. So, okay, so I can just leave it as that. Okay. So there is my equation. That's what we were just asked to find. Now in part D, it wants me to interpret the slope of the line. The slope is the 0.0446, okay? So when this is the slope and I need to interpret it, I'm saying for each unit increase in X, my Y will either increase or decrease by the slope. increase means the slope is positive, decrease means the slope is negative. So it's positive. So for each increase in x, my y is going to also increase by the 0.0446. I just need to put it into words. So I need to know what x represents and what y represents. So I'm going to say for each, I don't want to say unit. So I'm going to say day increase, because I know the units, it's day. So for each day increase, it's always about for each unit increase in that x, okay? Right there. I'm going to say in time on the shelf, to be a little specific, right? It won't always be that specific, but it's nice. The moisture, so when I talk about, when I talk about this, my y is the moisture content, right? So I want to say my y will increase or decrease by this. So my moisture content will increase, because it's positive, by that slope, 0.0446. And I'm just going to say on average. If you left off the on average is fine. I'm not that much of a stickler about it. Okay, that is my interpretation of slope. We've been calculating slope since you guys were in school, like high school, you know, like middle school really, but we never really, I don't want to say we never do, but often we don't put it into words, and that's all we're doing, we're just putting it into words. Okay. All right, part E. Part E wants us to write a sentence to interpret R squared. So I'm going to just write what R squared is. Remember, R squared is actually R being squared. So, but our calculator gives it to us. We don't have to do that and make a possible error. So I could see, I don't know why my lighting also got really bad. 0.9, that's because the sun went away, I guess. 0.90746. So I'm going to say 0.907, and I'm going to round properly, 5, okay? That's my R squared. Now I want to interpret it. Remember, this is saying that R squared percentage, so 90.75% of the variation or spread in my Y. So I'm going to say in the moisture content can be explained, and it's not by X, it's by the line, the equation of the line. You can even put it in here if you want. Right there, okay? So you can put the equation right in there if you want. That's my definition of my R squared and the meaning. F. So F here, says a line with a good fit has a value of R squared close to what number? Well, I need to remember 0 is less than or equal to R squared, and R squared is less than or equal to 1. So the closer to 1, the better. So think about it, because if R, my correlation value, 0.95, that's really close to 1. That means it's a pretty strong relationship between X and Y. That means that my line can explain a lot of the spread in my Y. So anything closer to 1 is better. So the answer here will just be 1. Do you guys have any questions on that one? I feel like I kind of zipped through it. I just wanted to make sure I got through it and we had enough time. And we did. Any questions on that one?